here we go, ladies and gentlemen. We are going to be writing equations of polynomial functions, which turned out to be pretty easy to do as long as you are given a point and the x-intercepts or roots, if you will. The roots of the function are very important, where it crosses the x-axis. And multiplicity behavior, which we haven't talked about. So I'm going to briefly talk about that, and because I'm writing it down, I know that you're going to be writing it down too. Multiplicity behavior is how the polynomial behaves. So here is an example of a little polynomial, and you can write this down too. It's going to pass through -2 and 3 and 5. And it's going to look like this. Just a nice smooth curve passing through each of those x-intercepts at -2 and 3 and 5. So this is my nice little polynomial. I'm going to call it P of x for polynomial. And you can see that right here at these x-intercepts, our curve is passing through it. It's just crossing it, crossing the x-axis. I call that a pass. It passes straight through. That's another pass. It passes straight through and another pass. All right, here's another example. This one's going to cross at -1 and 3. However, this one comes up, hits the curve, bounces back down, and then extends through 3. Thank you, my dear. So here, this polynomial is doing something very different at -1. What's it doing at -1? Is it crossing the axis? No, what would you call that? I call it a bounce. Does it appear to be bouncing to you? It sort of hits the axis and bounces off, kind of like a ball would. All right, do you see that? Does that seem like a bounce to you? Okay. Versus here at 3, what does that one do? It passes straight through. Okay, let's do one more. Here's one more. This one's going to go through -2 and +2. And this one is going to look like this. Boop. Boop. All right, this one has 2 x-intercepts. And what's it doing here at -2? Again, it's another kind of bounce. Well, that's interesting. And then at +2, what's it doing? Also bouncing. Okay. Ladies and gentlemen, this is the result of multiplicity. I can very easily write equations if I know, for instance, that x equals 5. What bubble did it come from to get that solution? What bubble did it come from to get an answer of x equals 5? X minus 5. If we take x minus 5 and we set it equal to 0, we would have to add 5 to both sides, and that's where we get x equals 5. Okay. If we know that x equals 3, what bubble did that come from? X minus 3. All we have to do is move the 3 back over with the x. We'd have to subtract the 3 back. Let's see. If I know that x equals -2, what bubble did that come from? Yeah, you'd have to add 2, move that 2 back to the same side, so you get x plus 2. Ladies and gentlemen, this is the equation of this polynomial. Look at that. Watch. So cool. Here we go. X plus 2 x minus 3, and x minus 5. I put in those bubbles. And let me just change my y-axis. Let's go to like negative 40 and positive 40. Let's look at that. Hey, look at there. And that's pretty damn cool, isn't it? I think it's totally amazing. Okay. All of these, at the zeros, they pass straight through because they are all bubbles to the first power. Okay. When we have a bounce, something slightly different happens. If we know that x equals 3, what bubble did it come from? Yep, got to subtract 3, and we get x minus 3. That passes straight through, so that's a little bubble to the first power. But here we have x equals negative 1. What bubble did it come from? X plus 1. Add the 1, and we get x plus 1. X plus 1. Now, because of the bounce, that is actually a repeated factor. It actually hits it twice. I like to think about it as a ricochet, okay? Anytime we have a bounce at our root, it gets a power of 2. That's the multiplicity. This is multiplicity 2. It hits it and bounces away from it, and that's why it has a power of 2. This, ladies and gentlemen, is a perfect equation. Well, almost perfect. It's not 100% perfect. X plus 1, quantity squared, times x minus 3. There we go. Put that in there. Let's see. See if we get a close match here. Hey, look at that. Pretty cool, right? I think it's pretty cool. It's amazing, isn't it? Okay. Ladies and gentlemen, last one here. Both of these bounce at these solutions for x. If x equals 2, what bubble did it come from? X minus 2. What's its power? Squared, yeah. If we know that x equals negative 2, what bubble did that one come from? X plus 2. And what's its power? Squared. Oh, that was supposed to be pink. Let's see what happens. Let's test it. Let's see, we have x plus 2 quantity squared, and then we have x minus 2 quantity squared. You'll notice they have to have x's in there in order to graph on an x-axis. Hey, look at that! I think that's pretty cool. Okay. I think it's pretty neat. You gotta say, that's pretty cool that we can pretty easily graph a polynomial, just knowing the x-intercepts. Okay, but we're not quite done. That, ladies and gentlemen, is a brief discussion on multiplicity, whether our graph passes through or whether it bounces. Do you give it a power of 1 or a power of 2 if it's a bounce? Okay? Let's take it one step further, though, and we're actually going to write the equation of the polynomial function. I'm going to simplify that graph for you. It looks a bit crazy. Write the equation of the polynomial function. And this is a very specific equation. Example 1, write the equation of the polynomial function. You can draw the general shape of that graph, and then we will label the points that are important together, because it's a bad graph, I admit. Write the equation of the polynomial function. This nice polynomial is passing through right here. That is negative 3. It's passing on the x-axis at positive 2 and positive 5. So those are the x-intercepts. Those are the roots. And then it also has this other point right here that is very important. And that point, which you might not be able to read, is 0, -15. Okay? That is an ordered pair that we're going to use to help us find the specific equation for this polynomial. So we are going to start by saying we know that x equals -3, x equals 2, and x equals 5. These are the x-intercepts, okay? Now, I'm going to take those x-intercepts and I need to convert them back to bubbles. How do I convert this back to a bubble? Yeah, you just slide that 3 back on the same side. You got to change the sign. X plus 3. X equals 2 in bubble form is what? X minus 2. Change the sign. X equals 5 in bubble form is x minus 5. Now, at all of these x-intercepts, what does the graph do? It passes straight through. They pass straight through for each of these, so they each just have that nice little power of 1. I don't have to worry about the bounce. They're not bouncing. Now, that's our start, but we have to figure out how to make this graph. It's going downhill from left to right. It has a negative leading coefficient here. What we have to do then is write our equation. Y equals A times all of this stuff. Our job is to figure out, solve for A. We can write our bubbles really easily. Our job is to figure out what we have to multiply by to make it pass through 0, -15. That's what this extra point is for. It's to help us solve for A. They are giving us a solution for x and for y. What should I put in place of y? -15. That's what they're telling me y is. And I am going to plug in place of all of these x's. What am I going to plug in for x? 0, yeah. So I have 0 plus 3. I have 0 minus 2. And I have 0 minus 5. All right, so we are plugging in the ordered pair. Whoopsie daisy. Plug in ordered pair for x and y. We're going to plug in the ordered pair that's on our curve, and that's going to allow us, you'll notice here, A is the only thing left. So we can figure out the A value. All right, let's see. We got -15 equals A times, what's 0 plus 3? 3. What's 0 minus 2? -2. What's 0 minus 5? -5. All these things are multiplied together. So I have -15 equals -2 times -5 is times 3? 30. So we get 30A. And how do I get A by itself? Divide by 30. Divide by 30. Woo. So we get A equals a lovely fraction here. What's this fraction? -1/2. Good. Divide both by 15. Is this an equation for our polynomial? No, this is an equation for A. It's the value of A. So we need to take that value and go back and plug it in. And that, ladies and gentlemen, is our equation. Y equals -1/2 x plus 3 times x minus 2 times x minus 5. Sorry, you can see that. This is an equation for our polynomial. That is exactly that polynomial. Can you take this equation and plug it into your calculator? Absolutely. You can absolutely take your equation and plug it in. In fact, that's a great thing to do on a test. I have negative 1/2 times x plus 3 times x minus 2 times x minus 5. And I can graph that. I get this great polynomial. And I can also use trace on my calculator. Trace right there. And I can type in my x coordinate. My x coordinate is 0. And hit enter, you can see I get the y of negative 15. That's exactly right. Okay? Very cool. Questions on this one? All right, let's do another. Here we have a W-shaped graph. So you can make a little W sketch here. And this graph has an x-intercept at 1 and another one at 5. And it's passing through this point right here that they have highlighted. What is that ordered pair up there? Zero, 30. Okay, so those are the important things. What do you notice about the graph at x equals 1? What's the curve doing? It's got a bounce to it. Bounce. And at 5, it's also got a bounce. It's hitting that x-intercept and bouncing off of the axis. Okay? And so I'm going to start with my x-intercepts. I know x equals 1, and I know x equals 5. What's the bubble form? X minus 1. Good, and I heard that that needed to be squared. Why does it need to be squared? Because of the bounce. Very good. What's the bubble form of x equals 5? X minus 5, and it gets a squared because of the bounce at 5 as well. So now we need to write a specific equation. What's missing? A. So we have to solve for A. We pop in a number in front, a multiplier in front, and that's going to make sure that our graph passes exactly where we want it to. What are we going to plug in for Y? 30. And we're going to plug in a 0 for X. So I have 30 for Y and 0 for my X's. And that's going to allow me to solve for A. 0 minus 1 squared, 0 minus 5 squared. All right, we've got 30 equals A. What is 0 minus 1? Negative 1 squared. 0 minus 5 is negative 5, and it's getting squared. I'm going to go through the math here. What is negative 1 quantity squared? Positive 1. It is negative 1 times negative 1, which is going to give me positive 1. Here, negative 5 times negative 5 is positive 25. So be careful. Can you use a calculator for those? Sure. Put them in your calculator. Use parentheses. Be careful. So we have 30 equals A. 1 times 25 is 25. So we have 25A. And how do I get A by itself? Divide by 25. Divide by 25. I have A equals, I can divide top and bottom by 5. So that's going to be 30 divided by 5 is 6. 25 divided by 5 is 5. So I have a fraction 6/5. Am I done? No, what do we got to do? Plug it back into our setup right there. That is an equation that's going to be able to be graphed on an XY axis. Don't forget the powers. That's what most people forget. They forget to square those things. And again, can you check your answers? Absolutely. When in doubt, graph it out. Absolutely graph those on graphing calculator. Questions on that one? All right, raise your hand if you think you get this. Easy? Okay. Let's just do one more. We have a lovely little curve that is passing through -2 on the x-axis and also touching at 5 on the x-axis. And because you probably can't see that too well, it does have this point right here that's highlighted. 20, 40, 60, 80, 100. 0, 100. 0, 100 for that point on the curve. All right, I'm going to start with my x-intercepts. I know that x equals -2, and I know that x equals 5 are a couple distinct zeros. What's happening at 2? A pass straight through. And what's happening at 5? It's got a bounce to it. All right. So now, what is the bubble form for x equals -2? X plus 2. What is the bubble form for x equals 5? X minus 5 quantity squared. And why do we square it? Because of the bounce. Okay. What's missing here? An A, yeah, we got y equals A. So here's our setup. In order to graph something on an x and a y coordinate plane, our equation must have x's and y's. Okay, keep that in mind. We need an A to figure out, to make this a very specific polynomial. What are we going to plug in to solve for A? 100 for y. And 0 for x, alphabetical order. So we have 100 equals A times 0 plus 2 times 0 minus 5, quantity squared. Don't forget your power you wrote. That's important. All right, we're going to do some cleanup here. 0 plus 2 is 2. 0 minus 5 is -5, and it's getting squared. So I have 2, and then what is -5 quantity squared? 25. -5 times -5 is 25. Again, can you put this in your calculator? Sure, you can. I'm going through the math because we make sure we know how to do that. We can multiply 2 times 25 together and get 50 times A. How do we get A by itself? Divide by 50, divide by 50. So we have A equals 2. Are we done? No, not done. That is not an equation you can graph on an XY plane. Doesn't work. We're going to take that and plug it back in for A. So we have y equals 2 times x plus 2 times x minus 5 quantity squared. That is our equation of the curve. All right, ladies and gentlemen, do you have any questions for me? All right, you guys have a test on Friday. Test on Friday. I have updated your grades. Please check your grades. And use this day to get today's assignment done. It's in Delta Math. And finish up some other stuff and send me an email. Okay? All right, good.